Hey everyone, we're live. My name is Brita. I'm a student advisor here at the Firehose Project, and we have Ken here today. He's our co-founder and CTO. So thank you so much for joining us. We're really excited to be talking with you all today. Our topic of the day is algorithms. It's a big topic, big part of our course and becoming a developer. And it's a question that we get a lot, just what are algorithms? How are they used? I think they become a little intimidating to people that have not had any experience with them or have a solid understanding of what they are. So we want to kind of break that down, talk to you about what they are, how you can learn them, how they're used, all that good stuff. So before we get into that, just a little bit of an overview. So we're going to spend some time talking about that. If you have any questions about algorithms, about our program, coding in general, feel free to put your questions in the box and the side of the live broadcast, and we'll be sure to answer those and get back to you. You can also send questions at any time to questions@thefirehoseproject.com, and we'll get back to you with that. We can always answer your questions, chat further, send you info. So we love to hear from you. Make sure you send us an email there if you have any questions. And you can also set up a call with me if you want to chat further about your specific coding goals. I'm definitely going to share a lot of information now, but I'd love to hear from you, what you're looking for. So we can chat further. I can provide any more information and see if this program and coding might be a good fit for you. So after we speak about algorithms, we'll kind of dive into our program a little bit more. And so we're going to be looking at things like industry trends with coding, job demand, what it's like to work as a developer, and then looking at kind of our course offerings. So what we teach we'll go into some of the logistics, kind of our course pace, tuition, what it's like to be a Firehose Project student, our curriculum, projects, support, mentorship, how we prepare you for a job, all that good stuff. So there's a lot of information, but let's kick it off with talking about algorithms. So thank you, Ken, for joining us. So I think, like I said, we get a ton of questions about this from students that are thinking of learning how to code, and I think it's really kind of intimidating because it's kind of this abstract concept, and makes it seem like maybe you need to be, have a lot of background to pick this up or be a math whiz or whatever. So let's just start off, like what are algorithms on a really high level?
Yeah, so algorithms are something that I'm kind of excited about. It's one of the things that makes computers really interesting. So what algorithms really are, it's sort of like a just fundamental sort of like description level, is the ability to break apart something that's like big and complex into individual sub-steps that a computer can execute. And these steps need to be completely unambiguous. So it has to be very clear, first do this, then do this, then do this. And these types of algorithms are the type of things that computers are really great at running. So each line of code is like one step in a sequence of algorithms. And if you think about building like an actual algorithm and working through something, you can think about building computer programs that span many different lines of code instead of just being just a few lines of code. So algorithms is all about just breaking apart a big problem into sub-problems, small problems that are unambiguous and the computer can just execute on and sort of come back with the answer. So that's at a broad sense what an algorithm is.
Cool. So essentially it's kind of like you said, instructions, breaking apart problems. And so like Ken said, he's really excited about that. And people typically that really like looking at like logical thinking and problem solving and stuff like that really enjoy working with that and enjoy programming and coding. So definitely talk a little bit more about that too. But so I think that's a great kind of description and definition of that. Can we maybe get like a real world analogy or example? So I know in the email that I sent out about this, we talked about how algorithms are like making a sandwich. And so how would you describe that? And how do you think those two things can be equated?
I think it's a really cool analogy to be totally honest. And I think it sort of makes it really click sort of what the point is and sort of the abilities that we have as human that we sort of take for granted and sort of taking that away and sort of understanding. So it's kind of like making a peanut butter and jelly sandwich in the sense that there's a few different steps involved. So if you asked a typical person, how do you make a peanut butter and jelly sandwich? You'd probably say something like, I don't know, I get a couple pieces of bread and I like put peanut butter and jelly on it, put it together, and then I eat it because it's a peanut butter and jelly sandwich. But that's actually missing a lot of the steps in the process. So if you think about the actual steps, if you were to be meticulous and talk about every single one in like excruciating detail, you would probably start by sort of like going to your fridge. So you like stand up, walk to your fridge and open the door. And then you need to find the jar of peanut butter. And different situations can have different outcomes. If there is peanut butter in the fridge, well, that means that you can continue on the process and do that. If there's not, well, maybe you need to make a trip to a grocery store to buy it and find the actual grocery store and do that. Once you actually get the 2 jars of like peanut butter and jelly, you can have to open the jar. So that's another step that you have to take. And then once you open the jars, you need to find a knife and sort of go and get the knife, and then you can come back. And there's so many steps along the way. And as a human, it's easy to just say, all I'm doing is making a peanut butter and jelly sandwich. But if you actually think about step by step by step and go through all of the details, you can see that there's a lot of details that as human beings, we just take them for granted. So computers aren't like human beings where you can sort of leave this room for leeway. You need to tell it exactly what to do. So an algorithm is really like making a peanut butter and jelly sandwich in the sense that you need to specify all of the details, and it needs to be unambiguous. If 2 situations are exactly the same, the exact same outcome should happen. And that's one of the beautiful things about these algorithms is the ability to just scale and have a computer just execute on a problem and solve it almost automatically without you having to think about it, because it's going through all the steps that you sort of program it. So it's like really teaching a computer to understand the problem and how to deal with each of the different edge cases, which you could talk about with like these peanut butter and jelly sandwich examples.
Cool. I love that analogy. I think it really helps kind of like grasp the complexity of a seemingly simple and definitely like for most people really familiar situation when it comes to needing those detailed instructions. And then I think you kind of like hit on the next question is like, so why is this so important? How are they used in coding? And I think you started to talk about that with like, even though the way you just described that, it seems a lot easier to just have a human make a peanut butter and jelly. Like why, what are the benefits of using that? And it's like, you know, scalability, stuff like that. So maybe if you talk a little bit about why that's so important in programming and how algorithms are used there.
Yeah, totally. So one of the things that's really important in computer programs is for things to work consistently. So different users who interact with your web application in different ways should have things work consistently and like the same. And if it doesn't work, that's a bug and you sort of have to go and fix it. So understanding algorithms helps you understand like what are the steps that the computer is going to do, what is the user going to see, and how does this actually apply. If you think about programming, there's kind of 2 different sort of extremes that you can think about. There is the idea of following patterns. So basically some problems have been solved before, and if you've already solved a similar problem, you can just kind of go ahead and apply this sort of pattern that you learned, and you can do it without doing a whole lot of thinking, just applying the pattern. But the flip side is if you want to get like laser focused into some of the details, sometimes you actually do need to focus on this logic and these algorithms and think about sort of connecting all the dots and making the app work exactly as you expect, especially given a situation where there can be a lot of different nuances involved. So algorithms can help you build real-world applications that map to the type of products that you'll have to build when you're sort of on the job.
Cool. So yeah, so maybe could you give us like a simple coding example of how that might, like more specifically when you might use that and like how it would be implemented?
Yeah, so one of the cases that I love to think about and talk about when it comes to these types of algorithms is talking about potentially building like a chess game. So that's one of the things that we do at the Firehose project. We put you on a group project and you build this chess game. But the reason that we do it is it's just a beautiful example of when a web application can have some of this logic that isn't necessarily so straightforward, and you have to actually start thinking about, you have to have the ability to break down big problems into smaller problems and smaller problems and smaller problems. So the example of the chess project is so good because there are a a lot of different pieces that exist on a chessboard. And if you're going to build a game where you allow two people to play chess against each other, one reasonable expectation of a feature is you shouldn't let somebody cheat. So move a piece into a square that it doesn't belong. So in the process of preventing somebody from cheating or like moving it into a square, you need to figure out, how do you enforce the actual rules of chess? And like, then you have to actually dig in and think about like, well, what are the rules in chess, and how do each of the actual pieces line up to like the things that they're allowed to do? So which pieces can move where on the board? And if you think about like a pawn, they have a certain moving structure where they move up in a certain way, and if they're capturing a piece, they go diagonally, which is totally different than like a rook that sort of only goes vertically or horizontally. And then like the knight's even weirder, where it can like jump over pieces and stuff. Like other pieces have to worry about obstruction and stuff like that. But you can sort of talk, if you start thinking about the specific use case of like thinking of a chessboard and trying to limit the pieces from moving around on the board, well, these are all very specific cases. So you need to have the ability to sort of jump into the program, the web application, add some logic, add these like lines of code that will make it so it's enforced. So basically it will prevent somebody from playing the game in a way that's like not allowed. So it's in a concrete example of sort of when these algorithms come in, and they come in all the time. So the chess example is a nice example because you can think about all the pieces, but at real jobs where you're building web applications, a lot more of the application is going to be sort of complex and thinking about how to break apart this problem and scaling the code and working with that stuff. So it maps really well to sort of what you need to do. So learning algorithms is really important, but it also isn't impossible. So it's definitely worth doing.
Yeah, cool. And I know, so we'll definitely talk more about building out the chess project or the chess game and working on the team project. I know, like, just as you're talking about that and I'm thinking about all the different things that you kind of need to solve for in that project, it's definitely seems a little overwhelming, and so that's a huge part of like working on a team to tackle that and breaking down all of that kind of larger objective into like smaller tasks and stuff like that. So we'll definitely talk a little bit more about that. You just ended that with, you know, it's not impossible to learn. So how do students learn that? How do we teach that? We can go into that a little bit. And, you know, what kind of, I think I said in the beginning, I think a lot of students or potential students think about I think they're pretty intimidating algorithms, and they're, you know, worried that they're very mathematical, and, you know, you need to have, be like a genius to work with algorithms comfortably. And I think that's definitely, you know, not the case. Definitely they're not necessarily like super mathematical. It's way more logic, stuff like that. So we can kind of talk about like learning algorithms, how we teach those, both kind of on a high level and then like in our actual program.
Yeah, so I think algorithm sounds like a really scary word. I feel like there's like a lot of letters in it. I don't know what it is about it, but it sounds like it's like intimidating and difficult. But it is something that pretty much anybody can do. So if you want to think about breaking apart a problem, that's like one of the important parts about algorithms. So don't worry too much about it. You don't need to be a math genius. You don't have to have this like huge wealth of information about like math and that type of stuff. You do need some, math does apply. So basic arithmetic, things like adding, multiplying, dividing, like modulo remainder, which is one of the stranger operations that exist in math. But we talk about it in the prep course. And those things, that type of math background, it applies a little bit, but you don't have to be like a math genius. It's not like you need to be great at calculus and all that stuff. So you don't have to be great at math, but you do need to be able to sort of figure out how to break apart a big problem into smaller sub-problems. And the way that we teach that, and one of the most effective ways to learn that, regardless of where you're looking to learn algorithms, is to start small and sort of get bigger and bigger and bigger problems. So the pattern that we take is called coding kata. So kata is, it's a term that's used in, I believe it's martial arts, where you sort of learn by trial and error, and you sort of take that, and the programming community kind of takes that same idea, where it's like, let's take the sort of approach where we have a problem and we present it with you, and you take that one and you solve the challenge, and then you move on to the next one and the next one, and each challenge gets like incrementally difficult. And because the challenges at the end are very difficult, having these intermediate steps where it's a little bit less of a stretch and it's a little bit easier to go is one of the most effective ways to do it. So in our course, what we have is we have a number of different coding problems, coding challenges that build up on top of each other, that helps you go deeper and deeper and deeper. And it's one of those things where it can be sometimes a little bit frustrating, but then as soon as you solve the problem, the like reward and the like feeling of satisfaction after sort of accomplishing a difficult task, like it's really a rewarding experience to actually be solving them. But it also makes you really appreciate the lines of code that you wrote. So using coding kata, using coding challenges to learn algorithms is one of the best and most effective ways. So that's how we do it at the Firehose project.
Cool, yeah, and I know students that join us and that we hear from in the full program, that when they talk about that, and they're like, you kind of get like addicted to that like satisfaction once you solve it, and you're like so proud of yourself, and you're like just so stoked. You keep looking at your code that you just wrote, and they're like, yeah, that's like, you kind of get addicted to that. So it's always cool to hear that. And I think, yeah, a couple of things that you were mentioning is like the kind of level of math that is required is for the most part all stuff that we're going over in our free bootcamp prep course. So basic arithmetic, the modular thing, which if you don't know what that is, sign up for our free bootcamp prep course and we'll be teaching that there. And then similarly, we also do kind of use a bit of that coding kata like in the prep course. So you're learning like the first challenge, the first Ruby challenge is basically more or less just like basic math and arithmetic, and then we teach the modulo, and then the next challenge is going to kind of use a bit of both. And so you'll get a sense also for how we build up on that. And so concepts and you know, if you've never signed into a terminal before, and then all of a sudden you're kind of building upon these concepts, and so you can get a feel for how that's structured as well. So the bootcamp prep course is kind of a great preview for how we teach and how we do that, and you know, does teach kind of algorithms at a very basic level there as well. Cool. Well, yeah. So I guess the last question is kind of what do you think like make the best traits for someone to learn coding in general, and then just like what do you think is, I guess, required to like be good at algorithms in terms of like personal traits, and to really pick up on that and start being comfortable with that?
Yeah, I think one of the most important things is just having a strong attention to detail. So in programming, there's a lot of small nuances that it's important to sort of pick up on and sort of notice. The difference between a capital letter and a lowercase letter, the word being singular or plural, or things like that is actually pretty important. So if you're looking to get into programming, start noticing these small little things, because it's going to start to matter a lot more. Typos in your code, like typos in your email, are not a big deal. People usually can, like human beings can understand and sort of work around them, but computers are a little bit more rigid, and these types of like problems and typos ends up causing like problems. So paying attention, noticing the small things, and really picking up on that stuff is really important. One of the other things that's really important is noticing patterns and things that it kind of goes in together with the attention to detail, where you can sort of notice these small details, notice the patterns, make the generalizations, and see how things are working in general. Being able to take a problem that's big and abstract and thinking about making it into many different smaller problems that you can sort of like split apart and sort of compartmentalize is another thing. That sort of being able to break things apart and sort of think about things in isolation is something that's really helpful. And overall, just being able to read documentation, error messages, and things like that is pretty important too. So basically, if you focus on the skills that are important to be a good developer, it'll help you a lot while you're learning these algorithms and stuff too.
Cool. Well, thank you so much, Ken, for joining us. I know that's a really popular topic, lots of questions. If you have more questions about it, like I said, definitely feel free to post them in the chat and the side of the live viewer screen. And you can also always send them to questions@thefirehoseproject.com. I love talking about this stuff, so happy to get back to you, set up a call. If you'd like to chat more, definitely hit me up. Questions@thefirehoseproject.com. So with that, we'll kind of go into a little bit more about like coding education and our program, and what we teach, what it's like to be a student with us, all of that good stuff. And I guess to start, like, let's take a look at kind of why we're doing this, why you might want to learn to code, what the industry trends, job demand, stuff like that are looking like. So we were poking around. The Bureau of Labor Statistics has data that basically software developer jobs are growing 17% over 10 years from 2014 to 2024. And so to compare that, I don't know if any of you know, like, if 17% sounds like a lot or a little to you, but all other industries are growing at 7%. So it's more than double, and there's just an increasing demand for these jobs. And so we'll talk about like what those jobs actually look like and what kind of industries they're in. But basically this demand is increasing rapidly, and the training up of people that are able to fill those jobs is not. So there's a huge job demand. Companies basically can't fill these roles fast enough. And so, you know, the Firehose project is located in the Bay Area in Silicon Valley, which obviously has a lot of these jobs, but these jobs are all over the place, and they're in all different industries. And so taking a look at like what these jobs look like and where they are, I think, you know, obviously there are these tech companies. So you've got Facebook and Google and Microsoft, you know, companies like that we kind of maybe think of as like traditional techie jobs where they're hiring a lot of developers. But actually it's taking over. So there was this saying that software is eating the world, and I think that's more and more true than ever, and it's continuing to be true, and it's been the truth for the past, you know, if you look at how far we've come with different technologies in the past 10 years, you know, having Uber and Lyft reinventing how we hail a taxi and how we get around cities and stuff like that, and then kind of where we're going in the next few years, it's pretty incredible. So taking a look, you know, the example of like taxis, having an app where you can call a car and put in where you're going to go, and you don't even have to take out your credit card. Looking at like autonomous cars, and then looking at a lot more traditional industries as well. So like healthcare, education, insurance, all of those have web apps, and all of those are software powered right now, and they're becoming more and more so. And that's what people are kind of demanding and expecting from these types of services. So almost every, you know, insurance company has an online portal. Sometimes they have a mobile app, stuff like that. And then looking at things that are like food service. So where we have food delivery online, you know, there are all these new types of food delivery that are a little bit more like maybe more high tech, where they have an app and you can track the person. Then you look at, I mean, like ordering a pizza on Domino's, where you can log in online and customize your pizza and watch the person bring it to your door. That's all software. And so, you know, ordering a pizza is powered by software now. Same thing with like ordering flights. It's so funny to think back when you had to like call up the airport and ask them when their flight listings were, and all of that is a web app. All of that's software powered. Looking at things like retail, whether it's shopping online, Amazon disrupting retail, you know, how everything's moving to online processes. Agriculture, the postal service, like FedEx, they say FedEx is a software company that has like trucks and planes attached to it. So financial services, like the list goes on. And then you're looking at a lot of, I mean, an industry trend kind of that I've noticed a lot and is being talked about a lot is this whole subscription-based model. So there are now subscriptions for everything, whether it's your music, Spotify, whether it's how you watch TV and movies, you know, through Netflix. Amazon has their own version of that. So all these things are becoming subscription-based. An example that I really like, she'd probably be embarrassed that I'm talking about this, but my sister has a toothbrush subscription, and she loves it. And like things that you wouldn't even think of, all of those types of things are powered by software. So you can start to think just like these endless possibilities of where this type of skill set can take you in terms of careers and jobs. So that being said, like when I'm talking about this software, kind of what does that look like? And it can look like a number of different things. So what our course does is teaches you to be a full stack web developer. And so just like a little bit of background on what that is. Like when the internet way back when was a young thing, it was basically you could look at like a static page, you could look at documents online. And so now you think of how we use the internet, and we're uploading things, we're commenting, we're actually like contributing to what exists on the internet and what we're seeing on our page. And we can take actions that will, you know, affect what we see on the page, how we move through an experience on a website. And so anything that involves that is a web app. So think about going online and using Yelp, signing into Airbnb, looking for a flight on, you know, Expedia or Kayak or whatever you're using. All of those things are web apps, and that's the job of, you know, a full stack development team, and that's what we're teaching in our program. So that's kind of a like industry overview, looking at career trends, stuff like that. So let's take a look at our program and how we prepare you for that, the way that we go about it, what you kind of get with our program and what it's like to be in our program. So kind of just going straight into logistics, these are questions we get a lot from students. Kind of how long does it take, how much does it cost, how can I pay for it, what does the scheduling look like, stuff like that. So we do have 2 course paces. We have an accelerated and a moderate pace course. It's going to be the same curriculum and program. The accelerated pace is 22 weeks, and that's about 25 to 35 hours per week of coding. The moderate pace course is going to be 42 weeks, and that's about 10, maybe 12 to 15 hours a week of coding. Again, same program, different timeline. Those do have different tuition costs, and we do have payment plan options available for both programs. So you can break the cost of tuition across several months, across basically the duration of the course. And then we do have financing options available as well. We have those available for our 22-week program right now. They're coming shortly for our 42-week program. So you can actually apply for financing if you're based in the United States. So for more information on that, you can visit our website, thefirehoseproject.com/tuition. You can also shoot me an email, happy to chat further and kind of go over options. That being said, we are one of the more like competitively priced, affordable programs, especially given the value in our program. So a lot of that includes our curriculum that we developed. We started teaching actually in-person courses. We taught at Harvard, Babson, Brown, RISD, Carnegie Mellon. We learned a ton from teaching in person. So we learned kind of what are the most like common gotchas, where do people get stuck, how can we explain things better? When we explain it like this, does it make it click for people? And one of the biggest things is we learned really from real-time feedback of having a classroom in front of us is how we can provide the right content at the right time to really accelerate your learning and organize the materials, because there's a lot to learn, in a way that makes sense so that you can progress through that at an awesome pace and really have things sink in. And so we were able to kind of transfer all of those lessons to an online program. And so there's a lot of benefits of teaching online. And so we'll definitely get into those. But I think part of why our program and our curriculum are so awesome and really make things click and allow students to learn these concepts at such a deep level is because we started teaching in person and really translated that experience to an online program. So in addition to that, we wanted to make sure that you get the support and everything that you need, even though you're coding online. And so we have that built into our program in a lot of different ways, and we'll definitely talk about that. So kind of looking at if an online coding program sounds interesting to you, what does it look like to be a Firehose project student? So a lot of what Ken was saying, kind of looking at like who makes a good student, stuff like that, a lot of what Ken was saying is true. So one, definitely like a passion for coding, a passion for learning, problem solving, puzzling. Ken and I were talking a little bit about like that really awesome, like addicting kind of rush when you are able to solve these challenges and break down large projects into pieces and work through the logic there. So if that sounds interesting, if you like thinking about like different logic and steps and all these different solutions and stuff like that, coding is something that will probably appeal to you a lot and be really fun for you. So it's a really kind of creative actually job, I think, more so than people think, because you're constantly thinking through like processes and logic and how you can improve and make them more efficient. So attention to detail, a passion for that kind of like puzzling, all of that type of stuff are really, really key traits of people that end up being good coders and that enjoy this and make good students. And then, that being said, we do have students of all different backgrounds, and that's what makes our Firehose community so awesome. So we have students from all over the United States, all over the world, actually, mentors internationally as well. and all different backgrounds. Like we have some students that are, stay-at-home parents and looking to get back into work, and this is what they really want to devote their time to and are passionate about. We have people that come from IT backgrounds, kind of admin backgrounds, retail backgrounds. We have had like personal trainers that have taken our program and then made these awesome kind of like fitness apps and stuff like that. So you can really, there's so many different kind of like past backgrounds and interests of people that come into our program that make it this really awesome, diverse community where you can really learn a lot from other people and their experiences as well. And it also just goes to show that we have students that have, full-time jobs, part-time jobs, families, other obligations, and are able to kind of work our curriculum and program into their schedule, because you can really sign on and code when it makes sense for you and your schedule. So I think that's a big part of what makes online learning so beneficial, in addition to kind of the support and other resources that we'll get into as well. Yeah, so I think with that, let's take a look at that. So what does our program look like? What kind of support do you get? What are you learning? So in terms of support, because I think that's a big thing with online programs, you want to make sure you're not coding alone, you're not getting stuck without any help. So that's a huge part of our program, and we also realize that beyond just like when you need help, if you're getting stuck, we want to give you tons of feedback and really help you level up to becoming a self-sufficient, awesome programmer. So we do that in a number of ways. So one of them is that we are there when you need it. So we are there when you get stuck, and we do that mostly through our forum, which is at the bottom of every lesson. So you'll see that in the Bootcamp prep course. If you have not started the Bootcamp prep course yet, definitely do it. It's super fun. We'll teach you some really basic algorithms. You'll get that coding kata experience, and you can chat with our team. So there's a forum at the bottom of every lesson. If you get stuck, can't figure something out, have a question, you can post in there. It's an awesome medium for that, because you can attach a screenshot or copy and paste your code, and we can take a look at it, help you out. Maybe it's just a typo or something like that. Or maybe you're kind of going down a rabbit hole and we can get you back on track. But our Firehose team, engineers, ambassadors monitor that and get you really quick answers so that you're never stuck spinning your wheel and being held up from something like a typo, because that happens when you're starting out and maybe don't know how to read the error messages and figure it out for yourself. So we want to be there to help you. So the forum is a great way to get that support. We also do have community channels. So we have Slack channels, we have Google+, and we have our community page. There's always students chatting in there, talking about questions, their experience, challenges they're running into, talking about their job search, the jobs they're getting, stuff like that. So we have our alumni, our team in those channels. And then a huge part of our program is the mentorship. So you get matched one-on-one with a mentor. All of our mentors are full-time programmers, so they have years of experience. They're currently working in programming jobs, and they're fresh. They're learning the latest technologies. They're programming every day. And so as someone who's just starting to learn how to program, it's a really valuable experience to get matched with a mentor and be able to kind of leverage their knowledge. So great things that you can do on a mentor session are a pair program, get a chance to have them review your code, work through challenges that you're having in the course, and really just each time get through these like high level challenges and topics that each week you're running up against, and have an expert really help you out with that. And then we always have office hours as well. So we have weekly office hours where you can meet other Firehose students, chat with Ken and Marco, get your questions answered, hear other people's questions. And so that's really beneficial. So in addition to that, I guess it's kind of part of our curriculum, but you'll also be getting regular code feedback and code reviews from the Firehose team. So that's a really important part of improving as well, is having someone look at your code and talk about how it could be more efficient, or be executed better, and really look at that on a high level and give you that feedback. So one, it helps you learn, and two, that's how it's going to work in a dev job. You're going to be getting feedback, hopefully, if you're with a team that really values that. And so you're going to be learning how to incorporate that feedback and how to talk about feedback and receive feedback as well. So there's a ton of support built in, so that you're basically never coding alone, and we're always accelerating your learning and answering your questions and challenging you to always improve as well. So our curriculum, which you can, just as a note, you can preview our curriculum If you're signed into the Bootcamp Prep course, there's a preview full program link up at the top. And that will actually go through all the projects that you'll work on and technologies that you'll be covering. So I'm not going to get too into detail on that, but we'll kind of do an overview. And that's something that I would love to talk more about. And we can give, project demos, stuff like that, in a one-on-one call if you're interested. So definitely reach out via email, and we can set up a call and look at some of the lessons and what this all looks like. But in general, so we teach Ruby on Rails and JavaScript, and we have a really strong focus on algorithms, of course, and data structures, and then just teaching computer science fundamentals. So we're teaching object-oriented programming, test-driven development, and giving you a really solid foundation so that you can continue on to keep learning and keep progressing your career as a developer. And so this is why a lot of our students graduate and they're getting jobs, sometimes in other languages, and they're getting jobs using Java. We've had students graduate and get jobs as iOS developers. And I think the reason why that is because they're learning how to use algorithms and use computer science to really break apart problems on a high level, and think through these problems and approach solutions. And so once you start getting comfortable with that, it gets super easy to look up how to use, a different syntax from a different language or a different technology, or a different framework, because you've got this core understanding of how programming is used to effectively, have computers approach problems or opportunities. So we give you really versatile skills that act as a building block and foundation of coding. So that being said, again, we teach, 2 languages, and then we're focusing on, working with databases. So working with like PostgreSQL and other frameworks within those languages that are going to help you, to build out features and start getting that exposure. And you're going to build out 5 apps throughout the program. So you get this repetition of working through, the whole process from wireframing to building out these apps and launching them live online. And so that is all kind of culminates in an 8-week team project at the end of the course. And so Ken was talking about this in our discussion about algorithms. And so why this is a really important project to work on just in terms of like technical learning and implementing your knowledge and your use of algorithms. So we talked a bit about that earlier in the session, and how you build out a chess app as a team, and it's a really complex project in terms of logic. There's all these different kind of moves that need to be programmed in, and rules and logic that you need to think through. What we didn't talk about necessarily in that was kind of the experience overall of working on a team and getting that experience and getting comfortable with that. And so that's a huge part of our program and what sets students up for success in getting jobs after the program, is that they have this experience working on a team for 2 months, building out a complex app that actually impresses interviewers because of all the logic involved and the algorithms involved. So that team project, you're working with a small group of other Firehose students with a Firehose mentor as your team lead. And the whole project simulates what it's actually like to work on a dev team. So you're using the same tools, the same workflow, you're using this agile team workflow, and you're having regular meetings where you have basically a dev team stand up, just like our dev team does, almost all dev teams do regularly. And so you talk about your progress, what's blocking you. And so you get used to using those tools in that communication like you will need to in your first job as a developer. And which means that as you go into interviews and you're getting through the job application process, you're able to speak to that experience and really demonstrate that you'll make a good hire for a team. Because I think that's actually a lot of what hiring managers are looking for. It's not so much, if they're talking to you, they know that you know how to code and how to build out things, and they're looking to make sure that you're going to be someone that's passionate about continuing to learn and problem solving, and that's also going to be a great member of their team so that you can really work effectively and cohesively as you're building out and approaching your targets and your goals. So the team project is how you're going to spend the last 8 weeks of the program. That's a hugely beneficial experience, and it really prepares our students for not only the job application process, but your first job as a developer. So we'll dive a little bit more kind of into job prep, because we do have specific job preparation in the Firehose project beyond just teaching you, what you need to know with computer science fundamentals and programming, and then giving you this experience of the team project, in addition to like the mentorship and all that. So we actually have a whole job preparation unit, and so it's 50 plus lessons. We actually built it out with a lot of feedback from technical recruiters and hiring managers. So we got awesome kind of insider insight on what they're looking for, how you can be a standout candidate, how we can, how they run technical interviews, how you can crush that. And then we have a lot of insight from that from our team as well. So Ken was a developer at various companies, was a developer at PayPal, has been on both sides of that technical interview. So we kind of pack all of that knowledge into these job prep lessons. So what we do is we start at the very beginning, how to structure your job prep, how to, just leverage your network, how to find these jobs, how to effectively network with people and make sure that your resume is being read, stuff like that. And then obviously we give you very tangible lessons on like how to structure your resume, how to highlight your projects. We also talk about kind of softer skills of building your online brand, building your developer brand, blogging about code, how to really like have your passion shine through if they see your resume and Google your name or something like that. So if that makes any of you nervous, we also partner with a company called Brand Yourself, which basically does online personal brand cleanup, if you will. So it goes over like your social media profile, stuff like that, and really helps you polish your online brand in case you need that. And polish any dirt on there and then make it awesome. So you'll be able to work with Brand Yourself as well as part of our job prep. And then we go real deep into the technical interview. So breaking that down, what that looks like, giving you, practice with that. We're consistently giving you practice interview challenges and coding challenges throughout the course so that you get really comfortable with that. But we talk about what whiteboarding is, what happens in a technical interview, how you can kind of reverse engineer that and really shine in the technical interview. And so those are really beneficial. And then we actually go all the way into like accepting jobs, salary negotiation, and starting your first day. So all of those resources, as a full program student, you do have lifetime access to those current resources, and it just acts as this kind of massive resource as you're, doing your job search, starting your first job, getting your second job maybe. And so that's something that you will have lifetime access to. You can always refer back to if while you're working on the team project or kind of out there in the real world. That being said, we also have little plug, we have our advanced programming courses as well. So that's a separate program, kind of acts as our Firehose graduate program. And that's where we get deeper into additional frameworks, advanced topics, and it's basically ongoing learning. It's a great resource for once you've graduated the Firehose program, or once you've started your new job, or are looking for your second job, want to do specific projects, train up for things in your first job. So those are our advanced programming courses. They're great for kind of after our core program, which trains you to be a competitive full stack developer candidate for any job. So that is kind of an overview of our course of algorithms. Obviously, there's a lot more that we can get into. I'm sure a bunch of you still have questions or maybe want to explore a little bit more. So like I said, you can shoot us an email at questions@thefirehoseproject.com. That goes to me, so I'll say hello and reply back. And I would love to set up a call, so you can also set up a call with me. And we can chat one-on-one. You can tell me what you're thinking, if you have any questions, reservations, if you're not sure if this will work for you. If you are sure it'll work for you, I'd love to hear from you, and just give you some more information about our program. And so we can take a look at, apps that other students have built, apps that you'll build out in our program. We can give you a kind of sneak peek or a demo of what the actual full program platform looks like. So definitely reach out, set up a call, and we'd love to chat with you. And then a great way also to kind of preview our full program and get a sense of if this is something you enjoy is by working through the lessons in the free bootcamp prep course. So that kind of acts as a preview for the full program as well as our admissions or acceptance process. So there'll be some little challenges, and really similar to what Ken was saying with the coding kata kind of style of teaching. So each concept and each lesson is going to build on itself, and then there'll be a little challenge at the end. And so As you work through those challenges, we'll actually be giving you feedback from our Firehose team, so you can start getting your first coding feedback. And then once you get the full thumbs up for all of those challenges, we can accept you into our full program. And so at any point, we love hearing from you, answering questions, chatting on the phone. So definitely reach out, and we'll look forward to hearing from you, having you code with us, and answering any other questions or feedback. Hope you all have a good night, and thank you so much for joining.